You know, we like to think we've got a pretty good handle on our place in the cosmos. But what if I told you we don't even agree on something as basic as how fast we're actually going? We're about to dive into a really fundamental puzzle about our own speed through the universe.
It all comes down to what sounds like a simple question, right? How fast is our solar system moving through space? Seems like something we should just know, a number you could look up in a textbook. But the truth is, the answer is anything but simple. In fact, it's leading physicists into a major cosmic mystery. Now, don't get me wrong. We do have one very, very precise answer. By measuring our motion against the cosmic microwave background, you know, that faint afterglow of the Big Bang, basically the universe's baby picture, we get a solid, reliable speed. Think of it as our local cosmic speed limit. And for a long, long time, everyone was pretty happy with that answer. But, and this is a big but, that local measurement is just one side of a much bigger and frankly much more confusing story. Because when we measure our speed in a different way, we slam right into what we can only call a cosmic speeding problem.
And check out the sheer scale of this problem. When scientists measure our speed on a more global scale, using the movement of distant galaxies as their benchmark, the number they get isn't just a little bit different, it's a staggering 3.7 times faster. Now, this isn't some small rounding error. This is a massive, glaring contradiction.
And I really want to stress this point. A discrepancy this big is a huge deal. It's a direct challenge to the standard model of cosmology, our fundamental rulebook for how the universe works, often called the Lambda CDM model. When two of your most trusted, most reliable measurement techniques give you wildly different results, well, that signals a potential crisis.
So, how is this even possible? How can two well-established methods for measuring the exact same thing be so completely at odds? Let's break down these two measurements to really get to the heart of this mystery.
So on one side, you have our local measurement. This uses the CMB, that echo of the Big Bang, as a kind of stationary backdrop for the whole universe. We look for a blue shift in its light, which is just a fancy way of saying we see how fast we're moving towards it. On the other side, you have the global measurement. This one looks at the light from super distant galaxies and analyzes an effect called Doppler boosting. Basically, things moving towards us look a bit brighter. Both of these are gold standard, rock-solid techniques, and yet they produce this impossible result.
And this brings us right back to the core problem. As this quote from the research makes crystal clear, our best model of the universe, well, it's got no explanation. The Lambda CDM model just cannot account for this difference. It's a genuine theoretical problem, and it's screaming for a new idea, a new resolution.
But what if? What if the problem isn't the measurements at all? What if the problem is our fundamental understanding of motion itself? This leads us to a pretty radical, but incredibly elegant new idea. What if we aren't just moving through space? What if we're also surfing the very fabric of space-time?
This idea is called the One Fabric of Reality model, and its central concept is, well, it's pretty profound. It says that space isn't just an empty, passive stage where everything happens. Instead, it's a single, unified, and elastic fabric. And here's the kicker. This fabric has a wavy character. It's rippling with these enormous cosmic-scale waves, almost like the surface of an ocean.
And this analogy just illustrates the solution so brilliantly. Think of our solar system as a boat on the ocean. Our local speed, the one we measure against the CMB, that's like the speed coming from the boat's own engine. It's our motion through the water. But of course, the ocean itself has currents and giant waves. That motion, the movement of the fabric itself, is also carrying us along. So our true motion is actually a combination of both of those things.
This simple little equation is where it all clicks into place. Our true total speed is just the sum of our local speed through the fabric plus the speed of the giant wave of space-time we just happen to be riding. Suddenly, the two measurements aren't wrong anymore, they're just measuring different parts of our total cosmic motion. The CMB measures our engine speed, while the distant galaxies are measuring our speed plus the speed of the wave.
Okay, so that's a beautiful and really compelling idea, right? But in science, an idea is only as good as its ability to be tested. So how on earth do you go about testing a theory about the entire universe? Well, it turns out the researchers have a very rigorous plan. It's a really clear three-phase research plan. First, you have to do the really hard work of developing the mathematics to precisely describe this wavy, elastic fabric of reality.
Second, you build a massive computer simulation to see if these waves sloshing around over cosmic time can actually reproduce that very specific 3.7 times speed factor. And finally, the ultimate test. You go back to all of our existing observational data, all those telescopes, and you hunt for the unique fingerprints these waves should have left behind.
So let's just step back for a moment and really think about the stakes here. What if they run these tests and the evidence holds up? What if this model turns out to actually be true?
The implications, they're just enormous. This wouldn't just be about fixing some quirky measurement problem. It would represent a true paradigm shift in physics, fundamentally changing our view of space-time from a passive backdrop to an active, dynamic player in the whole cosmic drama.
And the researchers behind this proposal put it perfectly themselves. They said this work promises not merely to adjust our models, but to fundamentally reshape our understanding of reality itself. I mean, that's the real potential here, a completely new, deeper vision of the universe we live in.
And all of this leaves us with one final, fascinating thought to ponder. If it's true that we're surfing along on some giant, unseen wave in the fabric of space-time, it just has to make you wonder, what other invisible currents are out there, shaping our cosmic journey in ways we haven't even begun to imagine?